working with probability, we studied what's probability and how can we calculate the probability of the events. In this section, we will study some rules for probability that generally we would use it for calculating the probability of the events. First of all, the probability, as we said, that probability of an event changes from 0 up to 1. The probability for sample space is equal to 1 because a number of event and a number of sample space, number of elements in even, number of elements in sample space will be equal. So the probability is equal to 1 and we call it a certain event. For two mutually exclusive events, it means two events which they don't have any common outcome. In this case, probability of A union B is equal to probability of A plus probability of B. But for any two events, A and B, it can be mutually exclusive events. It can be another events which they have common elements between each other. So the probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. As for mutually exclusive events, A intersection B is equal to 0. It means the probability of 0. So probability of A plus B will be the probability of A union B. Next rule, for any event A, probability of A plus probability of A complement is equal to 1. Because A and A complement makes what? Makes a sample space, as probability of sample space is equal to 1. So probability of A plus probability of A complement will be equal to 1. Or if we want to find the probability of A complement, it's equal to 1 minus probability of A. We will use these rules for solving probability problems. Here we say that we will use the rules for solving probability problems, but most of probability problems are written in natural language. So in this case, we should translate these natural language to algebraic expressions. Now, for example, one of them is the keyword for recognizing the union operation in written problem is or. It means that when the event A or B is written in a problem, it means we should change it to union, or we should think it as union. But the keyword for intersection operation is written as and. It means when it's said that the event A and B in the written problem, so it means that the intersection of A and B. It means that the elements which are which are in both, which are common in A and B, both of them. For example, a die is ruled. Find the probability that it shows 3 or 5. 3 or 5 means the union of them. It means 3 union 5. So first of all, we should find the sample space for this experiment, or this this experiment. Sample space for this experiment, ruling a dice is 1, 2, 3, 4, 5, and 6. We have 6 different possible outcomes for this experiment. But the question asks us the probability of 3 or 5. It means the event is event 1 is 3, event 2 is 5, and the question asks us probability of event 1 union probability of event 2. So it's equal to first of all, we should find E1 union E2. E1 union E2 is 3 and 5. So let's find the probability of E1 union E2. Probability of event 1 union event 2 is number of event 1 union event 2 over number of sample space, and it's equal to how many elements are there in E1 union E2? There are 2. And how many elements are there in number in a sample space? There are 6 elements in sample space, so 2 over 6, which is 1 over 3. So the probability of E union E1, it means, let me write it, 3 union 5 is equal to 1 over 3 for this problem. In this example, the question asks us an urn contains 5 blue marbles, 4 red marbles, and 6 yellow marbles. It means the total number of marbles are 15, 5, 4, and 6. We want to take 1 marble from the urn. What's the probability of taking a red or a yellow marble? Or means red union yellow, or A union B, the union of two event in this case. First of all, what's the number of sample space? As we see that the number of first of all, number of blue marbles is 5. Number of red marbles are 4, and number of yellow marbles are 6. So the total number of marbles, it means number of sample space, is equal to 15. And as the question asks us that the probability of red union yellow, as red and yellow are mutually exclusive events, it means at the same time a marble cannot be red and yellow at the same time. So they are mutually exclusive. It means they don't have any common element between each other. So the probability of these two types of event, it means A union B, was equal to probability of A plus probability of B. And we want to take one of them. So in here for this problem, we can say that probability of red or, I'm sorry, probability of R union probability of yellow is equal to probability of R plus probability of yellow. So what's, I'm sorry, this is, so now first of all we should calculate the probability of red and yellow. What's the number of red? 4. So probability of red is equal to red 4 over the number of sample spaces 15, so 4 over 15, and probability of yellow is equal to 6 over 15. So let's find the probability of red union yellow, or probability taking a red or yellow marble. So probability of red union yellow is equal to 4 over 15 plus 6 over 15, which is equal to 10, sorry, 10 over 15. If we simplify them, we will get 2 over 3. So what's the probability of taking a red or a yellow marble? It's 2 over 3. The next example, we have 20 cards numbered from 1 to 20. It means the sample space is all integers from 1 up to 20. A card is drawn at random. What's the probability of drawing an even number or a number divisible by 3? In here, again, we have two events, even numbers and numbers which are divisible by 3 between numbers 1 up to 20. So first of all, let's write the sample space. Sample space is 1, 2, 3 up to 20, all natural numbers or integers up to 20. So number of sample space is 20, and even number between them are between 1 and 20 is are 1, 2, 4, 6, 8, 8, 10, and 20. So how many numbers are there in set E, or even number between 1 and 20? There are 10 numbers. And a number divisible by 3, let me show it by 3. So it's there are 3, 6, 9, I'm sorry, 9, 12, 15, and 18. There are 6 numbers which are divisible by 3 between 1 and 20. As we see, between even numbers and set 3, or the numbers which are divisible by 3 or multiples of 3, there are common elements which are 6, 6, 12 and 12, 18 and 18. These 3 elements are common between even set number and the multiples of 3. So in this case we should use the other formula. What was that formula? Probability of E union 3, as the question asks us what's the probability of even number or multiples of 3. So or means union of them is equal to probability of E plus probability of 3 minus probability of E intersection 3. So first of all, probability of E is equal to probability of E. What are the numbers in E? How many numbers are there in E? 10 over number of sample space. What's the number of sample space? 20 plus multiples of 3, or the numbers which are divisible by 3 are 6 over 20 minus the numbers which are common or the elements which are common between even number and the multiples of 3 are 3 over 20, and it's equal to 10 plus 6 minus 3 is 16 minus 3, 13 over 20. So what's the probability of taking an even number or a number divisible by 3? It's 13 over 20. Check yourself too, is your homework. You can ask us your problems by our school WhatsApp number, and we will respond to you. Thank you. Next example, a number is selected at random from the 3-digit numbers formed using the digits 1, 2, 3, 4, 5, 6 and 7 without repetition. It means from these 7 digits we can make any 3-digit number but without repetition. 3-digit numbers we should form without repetition. Find the probability that the selected number is an even number. So first of all, in probability in problems, we should find what? We should find number of sample space. As we said, as the problem said, that the number must be 3-digit number. So from these 7-digit number, we should find, or we should make what? 3-digit number. So the number of sample space will be, if these 3-digit numbers, for each digit we calculate the number of choices. For example, this is unit digit, this is 10-digit, and this is 100-digit. So first of all, how many choices do we have for unit digit? We have, or for 100-digit, we have 7 choices, times for 10 digits, as the question says that the number must be, or the digits must be used without repetition. So if we use one of these 7 digits, so 1 is gone. So how many digits are left? 6. So how many choices do we have for 10 digits? 6 digits, or 6 choices. Times for another digit is also gone. So how many choices are left for unit digit? There are 5 choices. So what's the total number of 3-digit numbers which can be formed from these 7 digits? Is 7 times 6 times 5. But the question asks us the probability of the even number. So let's find the number of choices, or the total number of even numbers. 3-digit even numbers which can be formed from these 7 digits. Now again, even numbers are numbers which its unit digit must be an even number. As you see in here, how many even numbers do we have? 2, 4, 6. So we have 3 choices for even number. So 3 are one of them is gone from these 3 choices do we have, and what's the one of the digits are gone. So how many choices do we have for 100 digits? 6. From 7, 1 is gone, so 6 choices are left, times How many choices are there for 10 digits? Again, 1 is also gone, so 5. So 6 times 5 times 3 are the number of even numbers which can be formed from these 7 digits. So let's calculate the probability for an even number which can be formed from these 3 3-digit even numbers. So probability of even is equal to number of even over number of sample space, and it's equal to 6 times 5 times 3 over 1 times 6 times 5, and 6 times 5 are cancelled, so what's left? 3 over 1 is left. What's the probability for even number, for 3-digit even number which are formed by these 7 digits? That's 3 over 7. Another example, the machine generates all the 3-letter sequence of the letters in the word couple. It means from 5 letters you should make, or the machine makes what? 3-letter words with repetition allowed. It means in here in this problem you can use a letter twice or 3 times, it doesn't matter. Each sequence is written on a card, and the cards are put in a box. Omar draws a card. Find the probability that he draws a sequence or a word beginning with the letter K. In this problem again, we should find the number of sample space. Number of sample space as the word or the sequence is 3 letters, first letter, second and third. So how many choices do we have for first letter? 5 choices do we have. As repetition is allowed, we have 5 choices for second letter and third letters also. But for this event, that it says that the word must, or the sequence must begin with K. Again, for first, second and third letters, we have only 1 choice for first letter, which is K. But for second and third letters, we have 5 different choices, because totally we have 5 letters, K, A, B, U, L. So let's find the probability of this event. The probability for this event, probability of this event is equal to number of event over number of sample space. Again, what's number of event? It's 1 times 5 times 5 over number of sequences, 5 times 5 times 5. So 5 times 5 are cancelled, 1 over 5. So what's the probability for this event? The probability for this event is 1 over 5. Next example, the 6 people, including Murad and Samir, it means there are 6 people, are to be seated around a circular table. In here we have a circular permutation or circular arrangement. Find the probability that Murad and Samir are seated next to each other. And also for event we have circular and grouped element permutations. So first of all, we should find the number of sample space. As totally we have 6 people, but we have a circular permutation. So what was the number of permutations for circular table? For circular permutation, it was n minus 1. It means the number of sample space is 6 minus 1 factorial. But for event, as it's said that Murad and Sameh must be seated together, so we accept Murad and Sameh as 1 element and the other 4 people as another 4 elements. So the total number will be 5 elements in this case. So 5 minus 1 factorial for circular permutation, and Murad and Sameh also have a permutation between them. So times 2 factorial. So what's the probability for this event? Probability for this event is equal to 6 minus, number of event over number of sample space, or 4 factorial times 2 factorial over 5 factorial. We can write 5 factorial as 5 times 4 factorial, 4 factorial and 4 factorial cancelled, and it's equal to 2 over 5. So what's the probability for this event? It's 2 over 5. Another example, a box contains 4 yellow marbles and 6 red marbles. It means the total number of marbles are 10. 2 marbles are drawn at random. from the box. From these 10, 2 of them are taken or drawn. What's the probability that both marbles are yellow? Again, we should find number of sample space. Number of sample space as the total number of marbles are 10, and we take 2 of them, so a combination of 2 from 10 is the number of sample space. And for this event, as the question asks us that the probability of yellow marbles, so the total number of yellow marbles is 4, the total number of yellow marbles is 4, and we take 2 of them, so a combination of 2 from 4. So the probability for this event will be combination of 2 from 4 over combination of 10 from 2. And let's calculate it. 4 factorial over 4 minus 2 factorial times 2 factorial times 10 minus 2 factorial times 2 factorial over 10 factorial. And if we calculate them, because combination of 2 from 10 is 10 factorial over 10 minus 2 factorial times 2 factorial, and as it's in denominator, we should take its reciprocal and multiply it by numerator. And if we multiply them and calculate them, we will get 2 over 15. So what's the probability of that the both marbles are yellow? It's 2 over 15. I'm sorry, 2 over 15. And the last example, in a group of 13 people, 4 people speak English, 6 people speak Turkish, and 3 people speak German. A committee of 5 people is chosen at random from the group. It means from 30 people, we choose 5 of them. So the sample space, the number of samples, is a combination of 5 from 13. What's the probability that the community contains 2 English speakers, 2 Turkish speakers, and 1 German speaker? So first of all, again, we find the number of sample space. It's equal to combination of 5 from 13. 5 from 13. And what's the number of event in here? The event is 2 English speaker from 4, so combination of 2 from 4 times, and 2 Turkish, combination of 6 from 2, 2 from 6, I'm sorry, times, and 1 German speaker, 1 from how many German speakers were there? 3. 1 from 3. 1 from 3. So let's continue. The probability for this event is number of event over number of sample space, and it's equal to 2 from 4 times combination of 6 from 2. Let me write 6 from 2 from 6 and 1 from 3 over 5 from 13. And if we calculate it, we will get 30 over 143. So what's the probability of making a community with 2 English speakers and 2 Turkish speakers and 1 German speaker? It's 30 over 143. Check yourself. 3 is your homework. You can do it at home. If you have any problem, you can contact us with our school WhatsApp number, and we will respond you by the same color. Thank you for your attention.